Today I'll be teaching you about the life cycle of a star. Every day we wake up, but what really wakes us up in the morning? That's sunlight. Sun helps plants grow, gives life to living beings like humans through vitamin D and changes Earth's weather. Have you ever wondered if the sun's light would just disappear one day? Sun is a star like many other stars, just looks big in size. When we look at the sky at night, we see stars, but in various sizes. For example, our sun in the morning is the closest star we see. Why is it? Because it was formed long ago. But for stars which look small at night were formed a few years ago. Did you know that the sun's mass is 1.98 times 10 power 30 kgs? To imagine how huge the sun is, you would have to visualize 1,300,000 Earths squashed inside the sun in liquid form. Wow, that's a lot. Seriously. The mass of a star affects the lifespan and life process of a star. The larger the mass, the longer the star will live. Now let's begin the lesson with the beginning of a star. A star's birthplace is in regions of space made of gust, which is dust and gas. This place is called stellar nebula. It is extremely cold, almost at 10 and 15 Kelvin. What is Kelvin? It is a measure of temperature. Stars are born from a stellar nebula through two ways. The first way is by two nebulas colliding with each other, and the second way is when the nebula is exposed to shock waves at the explosion of a star. A shock wave is basically pressure released from the explosion of a star, which causes gravitational force. Gravitational force is a force that pulls objects near it and holds objects like Earth without making it fall. Thus, this gravitational force breaks the nebula into baby stars. The center of a baby star is called core, and the core is fueled with 98% hydrogen and 2% helium. The hydrogen found in the star is actually an element. This hydrogen is made of more simpler units called atoms, and the core of an atom is called nuclei or nucleus. Then a process called nuclear fusion takes place, which converts nuclei of hydrogen into helium nuclei. In this process, one hydrogen nuclei collides with two hydrogen nuclei, and they fuse together to form three nuclei of helium. Besides producing energy, the star appears brighter and becomes hotter, resulting in some baby stars to be bright or dim. The baby stars born from the stellar nebula are differentiated in two categories, a massive star and an average star. The life process of an average star is not much different from that of a massive star. Then, what's the difference? From the massive or average star up to the point of a red giant or supergiant stage, the only difference in the process is mass and color. Now let's continue with the process. Massive or average star stage is the main sequence of the star, as it spends 90% of its lifespan by converting hydrogen into helium. After a long time, the hydrogen in the star's core is all used up, producing no energy, and this doesn't allow the star to balance its gravitational force, which is shrinking. Then the star's core collapses, but there is still some unburned hydrogen left. So the temperature in the star's core rises, and the star does nuclear fusion. As a result, the outer layers of the star expand. After the unburned hydrogen has run out, the star does nuclear fusion again to produce energy. However, this time with helium nuclei, converting it into heavier elements like beryllium, carbon, etc. As the star does nuclear fusion, the star's mass increases and it becomes hotter. Subsequently, the outer layer cools down and forms the red layer. This is the red giant or supergiant stage, which takes up 10% of a star's lifespan. One surprising fact is that the mass of the red supergiant increases so much that it may be 100 times larger than its original size. Then, the red giant star turns into a planetary nebula, and the red supergiant star becomes a supernova. To enter these stages, the star's core completely runs out of fuel and the core collapses from not being able to balance the star's gravity. The time taken to do this is mere seconds in the supernova stage, but for the planetary nebula stage, it takes tens of thousands of years. Now you might think, then what category is the Sun in? The answer is an average star, so it follows the average star's process. From the planetary nebula stage, it will shrink into a hot and small planet called white dwarf. Then the star will cool down and turn into a black dwarf. Now, the stars which are massive turn into neutron stars, and the supermassive stars turn into a black hole. A black hole is a place in space where the gravitational force is so strong that not even light can escape it. Lastly, the substance released from the star becomes a nebula, and the process repeats all over again. Back to our previous question, was if the sun's light will disappear? Yes, it might. At the moment, the sun is between stage 4 and stage 5 of massive star, so the sun's got approximately 5 billion years to go before becoming a red giant and before the sun's light disappears. There's a hypothesis that scientists have made that we humans might get swallowed by the sun at the red giant stage. But is it really going to happen? Well, the future holds the answer. Thank you for listening to me. Bye!